Hello, my name is David and I am so excited to be here in Taiwan again, talking to you about mind reading with intelligent and adaptive user interfaces. Now, we all know that developing user interfaces is actually pretty difficult just because there's many things that can happen and there's also many ways that a user can use the user interfaces and applications that you build. For example, let's say that we have this fetch data button. Ideally, we click it, we get some data, and eventually it comes back with a response, hopefully a positive response. But what happens if this data takes a long time to load? We want some way to show the user that this data is in progress of loading, and so we might show a spinner or something until the data finally comes. However, if you're anything like me, then you'll know that you get impatient after waiting so long for the data that you just start clicking the button lots of times hoping that the data will come back faster. It never does. But you're a developer. You're smart. You think, I know, I will disable the button so that the user can't click it and then they have to wait for the data to come back. But I'm also smart because I'm a developer and I could open the DevTools and I could undisable that button and then I could just keep trying to make the request. The point is that everyone is different and we all come from different cultures and we speak different languages. This is my second time in Taiwan and I could say shishia and I could point to things at the night market that I want and, hold some Taiwanese dollars. But everyone is different and we all behave in different ways. So that's why I think that A/B testing, where we show either one user interface or another user interface to the user randomly, that's ineffective because that's only two possible options that the user might be able to choose from, when in fact, we would be better off building user interfaces that adapt to every single possible user. And also, user flows, which are how users go and navigate through the application, are not always linear. That means that a user might take one path, but a different user might take a different path through the application. And we have to account for all these different ways that users can use our applications. There is a library called guest.js, which uses predictive analytics to predictively fetch different parts of your application based on what the user is predicted to do. It was created by, I think his name is Sam Saccone at Google, and what it does is every time a user interacts with an application that has guest.js enabled, it sends analytics to Google Analytics and it reads those analytics back when the user uses the application again, and so it could predict if the user's on one page and they keep visiting another page, then it's going to prefetch the other page because that means that when they eventually do click that next page, it's already loaded for them. So it's a better user experience, it's faster for them, and you could generalize this with an entire group of users. So that's just one example of a library that could help with what's called adaptive user interfaces, also known as AUI. Now, an adaptive user interface is a user interface that adapts to the user instead of the device. And if you remember from a long time ago, one example of an adaptive user interface is Clippy. Remember when you would go on Microsoft Word or Excel and Clippy would jump up and say, I think you're typing this, or I think you're doing this, would you want some help? So that's the difference between adaptive and responsive user interfaces. So when we think about a user flow in an application, there's many different ways, like we mentioned, that the user could go. For example, if you're in an inbox application, they could see the newest mail or they could create a new email and then they could decide to either save that email into drafts or they could send it. Many different possibilities. So how could we take advantage of these varied user flows in predictive analytics? Well, we could measure, for instance, how often users are going to go from one path to the other. And then we could predict, just based on where the user is in the flow of the application, where we could prefetch resources and where we could adapt the user interface for them. So for example, you might have noticed this in Gmail. When you click a delete, when you delete an email or when you send an email, it will ask you, or previous applications asked you a confirmation. Are you sure you want to delete this? You would click yes or no. But it turns out that if you end up deleting or clicking yes a lot of times, then a better user interface would be when they click delete, it says deleted, because we predict they're going to want that action to be the default action. And we give them an option to undo that action if we want them to. And so this completely eliminates a step and makes the user interface a lot more pleasant to work with. So another example that's recent in Gmail is that this predictive text where as you're typing, it predicts what you're going to say next. And this is a really cool feature that I use all the time, especially on your mobile app. If you've used Gmail on mobile, you could just swipe and it goes to the next one. So that's really cool. So adaptive user interfaces are also good for power users because it could provide shortcuts for the power user to navigate through the app in the flows that he or she uses most often. And in the same notion, an adaptive user interface can help users that might not be familiar with the user interface and might need a little help by providing assistive guidance to the user. So both of them reach the same goals, and the power user can do their workflow faster, and the user who needs help can get that automatically provided assistance. However, this field of developing adaptive user interfaces, it's not a new idea. It's pretty recent. Around 2012, 2015 was the first research about these. But developing adaptive user interfaces is challenging because there's a lot of things to think about, and there's no strict system for what you should adapt and what you should change in response to user behavior. But we could consider the first steps to what we could apply to our development practices in model-driven development. And so model-driven development is creating a model of our application, and this abstract model describes how our application behaves, and we could use that to better support these analytics that drive these adaptive user interfaces. Now, you might be used to seeing this from a designer. These are user interface diagrams, and they show just how applications are supposed to go from one step to the other, from one screen to the next. They're also known as flowcharts, but more formally, you might recognize these as finite state machines. And so, just to review, a finite state machine is 5 parts. So first we have our initial state. So that would be the first thing that your user sees, for example, as you go in an application. And then you have a finite number of states, which are the states that the user can be in at any given time. Now the key is that you could only be in one of these states at a time. You also have a finite number of events, which tell you how the user or what can happen in the application, whether it's the user initiating the action or some other outside event, like a fetch response or a failure. And then there's transitions that go between the states, which say, when we're in this state and this event happens, this is the next state that we're going to end up in. There's also the notion of final states. And so when you're in a final state, that means that the application, it reached a terminal point and nothing can happen after that. For example, if you're signed out, you would have to sign in again because there's no further action to be done from there. So traditionally, finite state machines can be built with switch case statements in which you would first identify what state you're in this case searching. You would identify what the event that just occurred was. For example, a resolve, which we assume came from a promise. And from there, you would just say what the next state as a result of that is. Now, this is a little bit different than Redux from what you might see in the examples of Redux, in which it's action first. And so we're not doing it based on action first, we're doing it based on what state you're on first. Now, switch statements are all good and they're supported in almost every single language, but I like action mapping instead because number one, it's a little bit shorter and easier to read, and number two, we could just determine what the next state is based on this simple transition function. For instance, let's say that we're on the form state over here. So we could have our transition function look up that state, look up the events that just happened, like a submit event, and then if it doesn't map to any events, in this case it maps to thanks, but if it doesn't map to any events, then we just go back to the original states because we're saying that this state does not handle that event. Now, as mentioned, I created XStates a couple years ago, and XState takes that same idea of taking the object notation and making it into an executable state machine. So in this case, you would have the exact same object structure where you would specify the state, specify the event that just happened, and map that to the next state that occurs based on that event. Now, you can use XState with React as well. And so if you're using React, then you might be familiar with things such as useReducer. The use machine hook provided by the XState React package works in a very similar way. You have the current state, and you have a send function that's returned from the tuple of use machine, and you pass it in a machine that you created. Based on that, you could just match the states based on what the finite state of your application is. For example, if we're on the question state, we might want to render a question screen with various callbacks or various behaviors that could happen. For example, the user could click good, click bad, or it could close, and each of these can send an event back to the machine. Now, XState also works with Vue, Angular, Svelte, whatever other frameworks are out there. And that's because when you create a machine, you could interpret it as a service, and then you could subscribe to state changes as well as send that service events. Now, the next step from state machines is what's known as Statecharts, or hierarchical state machines. This was created by a computer scientist by the name of David Harrell in 1987, and it was created for the Israeli Air Force because their aircraft had very complex interfaces, and it had to be extremely precise to know which state you're in as you're operating one of these complicated aircraft. Now, Statecharts extends the notion of state machines by adding a few things. First of all, they add actions, which can be on entering a state, on exiting a state, and also transitioning between states. They also add guards, which make sure that certain conditions are met before a transition can be taken. For example, when we search, we want to make sure that the query is greater than 0. It also has the idea of hierarchy. So you could take these state machines and you could nest them into each other infinitely. Now, nesting I'll explain in a minute, but when you're in a nested state, you're also in the parent states and also in that parent's parent state. So it's a way of naturally grouping states together. There's also orthogonality, which is defining regions of states that don't really have too much to do to each other, but you could express that both of these regions are active at the same time. And there's also history, which describe that once you leave a state and you want to come back to that state, it remembers which child state you were previously in. So hierarchical states are great for grouping states. In this case, we have both the success and failure states grouped in here. And we're saying that the behavior of this is that whenever we search from any of these states, we could search again. So we have that same researching behavior. Now, hierarchical states are just a copy of the normal state machine definition in the object, but you can nest them inside of any one of the states. So for example, this search state, I just could have the same structure within here. And then I could define transitions either on the parent states or any of the child states as well. All right, so let's take a practical example. Let's say that I'm building this feedback form, and it has 3 steps. It says, how was your experience? You could click good, and then it says, thanks for your feedback. You could click bad, and then it takes you to a form, and you could fill it out, then press submit, and then it says, thank you for your feedback. Or you could exit any one of these screens, and it just closes the form. So this is what it looks like. You click good, it says, thanks for your feedback. If we rerun, we click bad. We could type something here, like no. Then it says, thanks for your feedback. Or in any state, we could just exit, and then it closes. So nothing too difficult. But we could describe this with the state machine, as shown here. All right, so this is just a traditional state machine that we saw with the switch case statement. So we switch based on which state we're on, such as question, and then based on whether we're clicking good or bad, it tells us what the next state is going to be. We use this with React, and of course you could use this with Angular or Vue or anything. And this is just a traditional state machine. You could also use XState for this as well. So here's our game plan. I want to improve this feedback form, but I want to do it in a way that's adaptive to the user. So first of all, we're going to create that abstract model of the feedback form in the form of a finite state machine. And then we're going to apply transition analytics, which is just determining how often certain transitions between states are taken. We identify which paths can be adaptive and which could change based on user behavior in real time. And then we use that analysis for adaptation and actually build that into the app. So we need to understand a few concepts before we do this, and this gets a little bit into graph theory. First of all is the idea of weighted graphs. So a directed graph is a graph connecting nodes together with edges in a certain direction. For example, signing in is connected to success or connected to error. Now, we could give each of these edges or arrows weights. For example, we could say that 90% of the time a sign-in leads to a success, and 10% of the time it leads to an error. And then we could show that the weight of the first edge leading to success is a lot more than the second edge. So when we think about our user interfaces this way, we have to stop thinking that each one of our transitions is equal. We now realize that over time, these weights can change. And the reality is that the user interfaces with an app in a way that users are more likely to take certain paths and less likely to take other ones, like the ones up here. So I did this sort of thing when I worked on the VS LiveShare team at Microsoft, which if you don't know what VS LiveShare is, you could go to aka.ms/liveshare, and it allows you to collaboratively code with anyone in the world. And so with this, there was sort of a complicated state machine within VS Code in order for it to work. For example, once you signed in, and of course there's a whole sign-in flow here, you could share a session, which means you're inviting others to join your session and to type along with you, or of course you could be the one who joins the session. Now, sometimes this leads to a success, sometimes it fails to share, sometimes you fail to join, and then you could leave the collaboration session, or if you're sharing it and you end it, then it just kicks everyone out anyway. So by adding analytics to each of these transitions, we created a weighted graph automatically that detailed what happened in a period of time and how often a user was able to go from one state to another. So we see over here that signing in, it most often went to this sign in. There's this externally signing in where it would take you to a separate window and say, do you want to log in with Microsoft or GitHub? But usually the user credentials were stored over here. And then we could see whether users were more likely to share a session or to join a session. And it looks like those are pretty equal over there. And then we could also visualize things such as errors. We could visualize how long each transition took and more with that data. So let's get back to our feedback example over here. We could click good or bad, but I want to make one path adaptive. And it's this bad path over here. And the reason is because we want them to finish the feedback form, but we don't want them to get annoyed with it. So I'm thinking maybe when they click bad, that we could take them directly to this thanks for your feedback screen and give them an opportunity to give feedback instead of annoying them and having them provide why they should give feedback. So let's take a look at what that looks like. So over here, if I clicked good, and then it says thanks for your feedback, and then I reloaded the page, now I have analytics on that transition. So that by that transition, I mean what state are we in, what event just happened, and how many times did it happen. So let's say that as a user, I click bad, and then I see this screen and I'm like, you know what, I really don't want to fill this out. So now we reload and we see that when I'm in the form screen, which is that can you explain why, I immediately close it. So I'm going to keep doing that because I really don't want to fill out this form. Now we could see when it reaches a certain threshold that when I click bad, it takes me directly to thanks for your feedback. And this is a very simple example of a user adaptive interface where it says, okay, the user really doesn't like filling the feedback form out, so instead we should take them to this thanks for your feedback form. And so this works in the reverse way. So let's say that I'm really having a bad experience, but I want to tell them why. So I would fill out the form and I would press submit. Now we see that the adaptive paths are going to change because we keep providing feedback and we keep taking a different path. So we see that the user behavior, the user being me, changes over time. And so now when I click bad, it will now take us back directly to that screen. And so this is something that happens as you see in real time based on those analytics, instead of it being over time and iterating back on the product. And so this really cuts the development loop for features such as this because it could adapt to individual users rather than just defining one set behavior for all users. So there's many ways that we could work with these, that we could analyze these transitions. One of them is by determining the frequency of transition. For example, let's say we're trying to make an Instagram app. We could see that, let's say that when we log in, we want to determine, do we show the gallery, the camera, or the profile view? The gallery being just a photo gallery of everyone's photos, the camera just being your photo because you really like to take photos when you open Instagram or WhatsApp or whatever you use, WeChat. And the profile page, which is just your profile. So when we take a look at these transitions, we see that reaching the gallery page is about 30% of people, reaching the camera is about 57%, and reaching the profile page is about 12%. And by reaching, I mean this is what the user chooses to do. So we see that once a user logs in this case, they immediately want to go to the camera page. So we could adapt that path and say, when the user logs in, for this particular user, maybe we should just take them directly to the camera page because that's what they're most likely to do. There's also analysis of events based on what we want the user to do. In this case, I'm using ads as an example, but I don't like ads. You could think of this in other terms. But let's say that we want to determine whether we want the ads to be interspersed in the gallery feed or shown at the very top every single time. So if they're interspersed and they scroll and they go through the ads, then maybe we want to assign a score of -1 because that's not desirable behavior. And if they're shown at the top and they immediately scroll, we assign a score of -10 because that's definitely not what we want the user to do. However, if they tap the ad and it's interspersed, we assign +10 to some sort of analytics score, or we assign +10 if it's shown at the top and they decide to tap the ad without scrolling. And so we could use that measurement and determine, should we show the ads interspersed or should we show them at the very top? And based on that, we could just optimize for what the user would want to see and where they would want to see the ads. So this gets a little bit more complex, and just like the first talk this morning about machine learning, decision trees are used a lot in machine learning and in making determinations about choices such as this. For example, on our on our Instagram example, we could determine, okay, are they a new user? And so maybe based on this data and based on the analytics, we could show the ad at the top, or maybe more information is needed, such as what's their friend count. And so now we could divide groups of users into smaller groups and use these decision trees to make decisions on what action to take or which paths to adapt. So there's many different ways that we could also make predictions on how we predict that users will behave. One of them is called the shortest path algorithm, and there's many different algorithms to do that, but we could use weights to determine what are the shortest paths through the application. And these usually determine what the happy paths or the paths that the users are most frequently going to take. Now, what I love about state machines, and especially using XState, is that you could provide those analytics right in the transition function over here, or the transition hook of a service. So now, having analytics to either track, trace, or measure what the user is doing is only in one call. There's one place you do it. You don't have to copy and paste it everywhere in your app. And so you could track what state did we come from, which is, or what state are we going to, which is the target state. What state did we come from, which is the source state. Which event just happened, and of course you want to sanitize this to prevent user details from leaking. And when did this event occur? So based on these analytics, we could see that sometimes the shortest path is not what it may seem. For example, if we're going from state A to C, the shortest path looks like A to B to C. However, based on analytics, we might reveal a different story, that users are more likely to go from state A to D to E to C, and in that case, the shortest path would be that A to D to E to C instead of A to B to C, which is less frequently traversed. Now, there's this other idea called higher order Markov models, which I recommend you looking up. We're not going to go in a big discussion on what that is, but essentially this is the idea. Let's say that you're in the state A, and you determine that 75% of the time we transition from state A to state B. So you might say, let's optimize and make an adaptive user interface for optimizing the transition from A to B. However, let's say that we extend that and say if the user is coming from state D, now they're much more likely to go to state C. So this really depends not on a single transition, but multiple transitions as well. And so that's what that higher order means in higher order Markov models. So we could also use deep reinforcement learning to further predict what the user is expected to do. And so we could do this over time because we have that analytics data. We could have a reinforcement learning agent learn over time and either punish it or reinforce its behavior, that whatever the user does, it eventually matches what the reinforcement learning agent predicts. And so we do this by providing it the environment, which is that finite state machine model of our application. And when we provide it actions, or sorry, when the agent decides what it should do next, it's going to continuously use that data in order to predict what is the user going to do next. And so if it predicts correctly based on historical data, it gets a reward, and then it improves itself over time. So overall, you could see that there is a much brighter future to developing user interfaces other than just taking a design, coding it, shipping it, and calling it a day. There's much more we could do. So when we create this executable model, we could track these metrics automatically, and then we could feed it into things like Google Analytics or Segment, Mixpanel, KISS metrics, what's it called in Azure, whatever. I work for Microsoft and I'm talking about Google this entire time. Please don't tell Microsoft that. So you take that and you feed it back into these adaptive transitions, and by that you make this adaptive user interface that adapts to your user. So this relates to the dev experience. When we use these abstract models, which are these state machines, we provide determinism in knowing when we're in this state and this event happens, we know exactly which state it's always going to be in. By providing that structure in that machine object format, we could automatically visualize these results. And so, of course, these are things that are very good for developers. But what's also good is that by having these visualizations, and especially having these metrics provided by analytics, we have communication between our designers and our stakeholders, and we're able to visually show them this is how users behave through the application. Now, we also have testability in which we could take these models, especially these models with analytics, and we could automatically generate tests based on that. I gave a talk at React Rally talking about model-based testing and how we could do this, so please look that up if you're interested in that. And we could also, of course, use machine learning and reinforcement learning to create simulation of how our users are expected to behave in the app based on this abstract model. And of course, we could use analytics and greatly improve the user experience by creating these adaptive user interfaces that adapt to them. So adaptive user interfaces are great because they create these personalized systems for every user instead of having a one-size-fits-all system for everyone. They prevent information overload because you could design these adaptive user interfaces to hide things that some users might not care about and to make more things prominent that the user is definitely going to care about. They do provide intuitive guidance for users who might not be used to using the system, and over time this guidance can seamlessly disappear so that power users can use it more efficiently, and it helps users understand tasks and goals as they're navigating through your application. There's a lot of modeling considerations that I want you to think about, and we're not going to go too deep into today, such as micro versus macro adaptivity. And that's, do we go on the micro level, or do we adapt the application as a whole? Things such as prediction versus feedback, local versus global adaptation, and whether we use data, which is real user data, which you want to be really careful about, or simulation data. Now, using state charts is useful for so many other things, such as with NASA, they use state charts to visualize they use it to visualize a Curiosity rover, the way that it behaved and the way that it was designed. And with that, they were able to create these precise diagrams, automatically generate code, provide complete testing coverage, and also they were able to adapt to people coming in and saying, we need this feature, we need to change this behavior, without being scared of breaking anything. Now, there are disadvantages too, in which learning state charts is, of course, a learning curve, and it's something you have to teach your entire team. Modeling does require planning ahead, and you can't just jump into the code immediately, and not everything can be modeled perfectly into a state machine or a state chart just yet. There's also complexity trade-offs, whether you use a finite state machine, which can exponentially grow in complexity over time. Using the traditional bottom-up method that we are used to coding, it just linearly grows in complexity. And state charts might be too complex for simple systems, but over time, it greatly reduces that complexity. And so, again, I'm working on X-states, and there's a whole ton of features and tooling that I'm working on. I just released X-state test. I'm going to be soon releasing this X-state analytics package to more help you manage analytics with X-state, and other things such as view integration, visualization, and simulation. And also there's a visualizer, which I feel is one of the most important points of X-state, where you could copy and paste these machine definitions and automatically visualize them and interact with them in real time. There's a lot of resources online for you to take your user interfaces to the next level and make your code do so much more. So thank you, JSDC.
那我们现在台下有问题的吗？
I really love this. I can see there might be some problems regarding documentation. Say on Google Doc, on Google's document, they'll have screenshots tell you what to do instead. With this adaptive UI, I can see that those screenshots, step-by-step screenshots, are no longer working. That's a real problem, right? And also, in the case of like some dumb people like me, I just never know how to get those. I never know where I should click. And sometimes I would even to make a phone call, I call them. Customer service people, they will be seeing different UI than what I'm seeing. So do you think there's a way to solve these problems?
Right. So what he was asking is there a problem when you're like with these user interfaces? There's the issue of they might be different for every user. And so that's definitely true. And that's one of the considerations on how much should you adapt the user interface. And it's still an open area of research. I mean, this is really cutting edge material. What I would say is that with these analytics and with having a system modeled in a very abstract but strict way, is that you could take the analytics of a specific user, such as, oh, they're more likely to do this, this, and that, and you could plug it in directly as a customer service representative and say, okay, I see exactly what they're seeing because I have their same analytics on what they're used to seeing. So they might be able to help you with things like that. But also, adaptive user interfaces are supposed to help the user, so not even involve a customer service person and just help the user itself. And so, ideally, eliminating that.
好，还有没有其他想问的问题？都没有吗？好，那就再次掌声，谢谢 David。
谢谢。